All right, so this is the final part of the structures of math project over uniformity of operations. We're going to go and look at multiplication in terms of rectangular array. And what a rectangular array is a visual aid that we can set up, a visual aid or a chart or graph that we can set up, and it helps us visualize a multiplication problem. So here you can see my problem that I've constructed is 10 times 11. And what I've done here is I've made 10 rows down of equal distance. We'll say that they're equal. And then I've went on the x-axis and went across and made 11 equal spaces. And what this is going to allow us to do is to count each individual square here on the chart and come up with our solution to 10 times 11. So what I could do from here is to now go through and count all of them. And for the sake of time, I don't want to do that. But I know that I'll get 110 because I know that 10 times 10, this would be 100. And then I can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 more. So I would have 110. And you can come in here, you can color in each individual box a different color, but it's kind of the main gist of how we use rectangular arrays to solve multiplication problems. Okay, so for my second problem, I want to do a fraction times a fraction. And I know that 2/3 is smaller than 1, and I know that also 1/4 is smaller than 1. So when I look at this problem here, I can make a box that's just 1 by 1. I would need to go out, like if this number was a 1 here, if it was a mixed number and there was a 1 here, well, I know 1 and 2/3 is more than 1 but less than 2, so I would have to make 2 boxes. So it's the same kind of concept here, where I know that 2/3 is less than 1, so I only need to make 1 box, or need to make 1 box by, well, 1/4 is also smaller than 1, so I need to make a 1 by 1 box, which is just a box. So I came up down here, already drew my box, and like we did before, we put one part of the equation on one side, the other on the top side. So this is the y-axis, this will be the x-axis. We'll put those on opposing axes, and then I know I need 1/4 of this line. So in order to do that, I came in here and drew 4 separate but equal columns within this this square. So I have 1 column, 2 columns, 3 columns, 4 columns. 1, 2, 3, 4. And in order to give me 1/4, I can come in here and shade in now 1/4 of that column. So I have 4 equal parts. I can come in here and shade in a 4th. Now, what this question is asking me is, what is 2/3 of 1/4? So, in order to find the 2/3, I'm going to do the same exact thing, but instead of making 4 equal sections, because this is a 3, I'm going to make 3 equal sections. So, came over here and made 1 section, 2 sections, and 3 sections. So all in all, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sections, parts in this one square. And then I also am going to need to shade in 2/3 of 1/4. So if we were looking at thirds, if I just filled in a third, a third, 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 there we go. The question, like I said before, is asking us what is 2/3 of 1/4. So what it wants to know is what is the overlaying portion of this problem. And if I come in here, well, I know I have already 12 squares. All I have to do now is see how many of them overlap. So I have one that overlaps and two that overlaps out of the 12. So it would be 12 over 2. Then we can translate this, simplify it, and I know that 2 goes into 2 one time, and that 2 goes into 12 6 times. I got my answer right there by just simplifying it further. For the next problem in our rectangular arrays examples, I wanted to do two mixed numbers times, or a mixed number times a mixed number. And we're going to start off the process the exact same way as we did the last one. I know that 1 3/4 is a little less than 2. So here in my rectangle, I'm going to come over and make a space enough for 1 and 2. Because I know that 3/4 is not necessarily 1, but is going to be bigger than uh, 1 because there's a 1 here. Then I know that 3 and 1/3 is bigger than 3 by 1/3, but smaller than 4 by 2/3. So what I need to do is now allow myself space to work within the range between 3 and 4 to show that 1/3. So what I've done here is I've already divided it. I've put 1 and 3/4 here up at the top. So I got 1, and then this in here will be my 3/4, and then on this side, my y side, I have 3 and 1/3. So I came down 1, 2, 3, and then in order to put my third, I made a fourth column. So now I'm gonna just draw my lines and fill it in and show you that. So first I'm gonna show you this. I just colored in my 1 3/4. So I colored in one whole section, and then I divided the second section into 4s because I know I need 3 of them. So I made it equal parts and did 3 lines and made 1, 2, 3. This will be 4, but I don't need the 4th. So I colored in 3 here. So I went over 1, colored in 3, and I'm going to do the exact same thing with 3 and 1/3. I'm going to come down 3 and then make my lines here and color in a third. Now that I have all of my areas shaded in, I can come in here and now count how many squares I have, add those all up, and then I'll find my answer to my multiplication number here, my problem here. So I can come in here and count that this is one hole, that's a hole, and that is a hole. So I have 3 holes in this shaded in area. And remember, we only want the shaded in area, so I can actually come in and get rid of this because I don't need that. I only want where they overlap. So then I can come over, and remember we divided this into 4 columns, so I can count, well, this was a 4th, that was a 4th, these are all 4ths, and I can go on and on and on here, but 1, 2, 3, 4, 5, 6, 7, 8, 9. I get 9/4. Now, for this portion, I know this extra little portion that I have here, I know that I divided my last quadrant into 3 equal sections. So I'm going to kind of know, well, if I cut this into 1, this into 1, and this into 3, or another one, I'm going to have 3 equal sections. So I can just come in here and add 1/3 because 1/3 is where they both overlap. And then here in this quadrant, they overlap, and it actually got cut into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It got cut into 12 sections. So I go in and I count 1, 2, 3 of them are overlapping, and I get 3/12. Now we're going to use this to find the answer. Now I have my equation, and I know that 4 goes into 9 2 times, so I can actually come over here and make that a whole number, a mixed number, in order to make this whole problem easier on myself. So I drop the 3 down, make this a mixed number, drop this down, and then I can simplify this and actually make it 1 over 4. Then I can move this off to the side, 3 plus 2, and it's going to give me just this portion to work with. Now that I have that, I know that 1 and a fourth and a fourth are going to be 1/2 plus the 1/3. So I'm going to combine these 1/4 just so that I can have a quicker and easier problem to work with. Then if I simplify this, I have to add both or multiply both by this by 2, this by 3. It's going to give me 6, and then I have to do that to the top as well. It's going to give me 5. So my answer is this, 3 plus 2, which is 5, and 5/6. Finally, for our last problem, we're going to do decimals. And I have the problem 3 and 3.5, basically, and 2.25. In order to do this, we're going to do the same thing. We're going to make our little box, our rectangle. And I know that 3.5 is more than 3, but less than 4. So I need to make 4 boxes to give myself space to be able to accompany the point or 0.50. And then I know that 2.25 is bigger than 2 but smaller than 3, so I need to make 3 boxes here on the opposite side to reflect reflect this number and make space for the 2.5 or 0.25. I'm going to fill this little thing in and then come back. So first I did the 3.5. So I went over 3, and then I went and divided my last column, my 4th column, here by 1, 2, 3 equal spaces. Or 4 equal spaces, I'm sorry, because I know that 25 is about a fourth of 1. So I divided my last box into 4 and then shaded it in. Actually, so I misspoke, and I needed 3.5, not just 3 3.25. So I'm gonna go ahead and that's why I divided it into the 4, and then I could do that. It just makes it a little easier for me to look at. Then I needed 2 and 0.25, so I came down 2. Then on my 3rd row, I know that 0.25 is less than 1, so in about a fourth of a whole. So I divided this into a fourth and then shaded all of it in as red. And then we want the parts that, again, overlap. So we want to count all of it. And so I'm going to count just each individual thing. So it's a box. So that's 6 right there. And then I'm going to have, these are both 1/2 because this is just in half right here. So that's going to be a half. That's a half, which makes a whole. And then I have 1, well, these are smaller, so they're not technically halves. So what I'll come in here and do is then count these. I'll make an equation and I'll come back to it. I kind of went ahead and solved the equation, but I'll walk us through. We had 6 whole pieces, and then we came in here and counted our fourths. So we came in here and counted our half made another whole. We counted our fourths here. Then, because this was divided like we did in the last section, we just counted how many squares we had. We have, all in all, we had 8. So we dropped down 1/8. And then we can use that to solve for our equation. So you can see I went through here and made the denominators the same, got 13/8. And then I just added my mixed number back into my 6 that I had from before, and we solve for this